Hello and welcome back to the DataPrime Academy course. In Module 7, we learned how to use the help system and understand things like scan limits. Now we'll master DataPrime's essential filtering capabilities. Today we're focusing on the filtering fundamentals, selectivity principles, basic operators, logical combinations, and the choose command. So these core skills will make your everyday queries both powerful and efficient. So remember from Module 7 that data volume matters more than the query syntax itself. Let's apply this principle systematically through smart, selective filtering. So what's the most impact on data volume? It would be time range. So that would be our source logs last 4 hours. Equality filters are very good for selective of categorical data. We have our subsystem front name, application name, cube system. System metadata, another good way of being selective. So looking for severity of our logs for errors, for example. Data fields, things like matching the status code or a user ID, for example. Some more rules around these severity enums. Don't need any quotes. For example, here, that's severity of error. String comparisons, use single quotes. Casting, use the colon notation. Now you'll see throughout this course that I'll explicitly use the casting. There's no performance benefit, it's just for visual purposes. DataPrime usually can auto-detect what the data type is. So the key thing here is the selectivity principle. So write filters for readability and logic, knowing that DataPrime's optimizer handles the execution order. Focus on choosing filters that eliminate the most data, regardless of where you place them in your pipeline. Let's take a look at some method notation. This is really good for making filters both readable and efficient. Here we have filtering by $D, starting with the likes of an API. We have $D message containing error. It's really powerful for pattern matching. And we have filter application name ends with prod, so good for finding out or stating which environment you want to be looking at. So the mental model is how much data does this filter eliminate, rather than where should I put this filter. Let's move on to some logical operators and building out those complex conditions. Let's begin again with source logs. Last 4 hours. Let's have a look at our payment system. So I want to go L subsystem name, and that wants to be payment system, payment service. Okay. And I want to use an AND operator, so everything matching the subsystem name of payment service. New line, let's use the AND operator, and it has to match this condition. I want the metadata, I want the severity level of error. Let's run that. So there we have almost 4,000 logs in the last 4 hours of payment service with error, and that would raise alarm bells for me. We can also use the OR operator. So say if we added another filter here, and we wanted to look at the payment type. So say if I wanted that to be a Visa, let's go Visa, or we could then use the OR operator, so new line, and the OR operator is 2 pipes. So we can do $D then. Oh, $D, that payment transaction, so it can be Visa, or we could have it match that of a MasterCard. So there we have it. We have 5,000 logs there on the last 4 hours of payment service with either Visa or by MasterCard. We also have a NOT operator, and that is used with a exclamation mark. So if I put in another filter here, and exclamation mark to exclude, $D for data, say something like here the URL contains something like health checks, for example. I'm just for purposes sake of this demonstration. That's in our single quotes, so I'll exclude anything that contains health checks. Lastly, I want to show the choose operator. Choose operator optimizes performance by selecting only the needed fields. So let's take away our last filter and let's use choose. And here I can, IntelliSense is working again. I can choose specifically what fields I need. So say I want the subsystem name, and say I want the timestamp. So separate that with a comma. And for timestamp, we need $M. And if I then run this, I'll just get those required fields. So to recap, practical guidance here, focus on selectivity and data volume. Let DataPrimes optimizer handle the rest. The performance mindset is think about how much data each filter eliminates, rather than where to place the filters, and write readable, logical queries, and trust the optimizer for the execution efficiency. In our next module, we'll explore grouping and aggregation, taking your DataPrime skills to analytical intelligence with advanced queries.